And today I would like to show you that PowerShell obviously is an island. It's more or less like a common denominator. And you've already seen how you can import data from different sources like XML or .NET objects or anything like that. And there's this built-in magic, the extended type system, that makes everything behave like an object, which is great. But there's also primitive data, unstructured data out there. And I'm sure you all have eventually the need for parsing a log file or otherwise transforming unstructured data into structured data. Which is why I would like to show you a couple of strategies that have proven quite useful in the real world to convert plain text into real PowerShell objects. Once you have objects, you have your set of 6 important commandlets that in most scenarios do the hard work, like all the object family commandlets: select object, for each object, where object, group, sort, like that. It's basically SQL, what's PowerShell using there. So how can we really get any unstructured information into this PowerShell common denominator object-oriented world? Well, I want to discuss with you first of all how you create your own parsers, which is obviously a little bit hard, but you can do it and you'll get a very specific parser for that. I'll show you how you can abuse existing parsers, because PowerShell obviously contains parsers already, and it's just a matter of sort of tricking them into parsing your data. And then we'll look into automatic parsing, which is part of PowerShell 5. And Jeffrey mentioned that in his talk this morning. That's the so-called example-driven parsing, where I don't bother writing any parsing. Instead, I'm supplying examples and then leave the hard work to a new commandlet. So first of all, what is a parser? Regardless of whether I create it myself or whether I use an existing parser, a parser has the job to translate unstructured information into meaningful pieces or tokens of information. And the keyword is meaningful. It's not providing any meaning, which would be interpretation. It's simply providing pieces or chunks of information, and then it's your job to interpret an IP address or a MAC address or whatever you got out of a text file. And this is a list of all the parsers that you can find in PowerShell already. And well, obviously you have used them before. So if you have XML data or CSV data, then you can use the appropriate commandlets to read it in and turn it into objects. But there's more. For example, here there's also a parser that interprets PowerShell code, which is going to be the topic of a session on Wednesday. That is a parser also. PowerShell code, after all, is simply plain text. And then there's, again, this new convert from string that I'm going to discuss a little bit later. So when we want to create a new parser, what's the job of a parser? A parser needs to, first of all, accept raw data, then apply some structure to it, and then finally, that's important, return rich PowerShell objects so that these objects can play in the PowerShell world, that I can sort them or send them to Excel or do whatever I want to. So the mission now, the first mission would be to create a parser for a log file. And to do that, the tools needed depend on your level. If you're a beginner, you can get away with plain text splitting operators. You'll see that in a minute. They're extremely powerful and they can be sufficient. Or if you want to go one step further, of course, you can dive into regular expressions, which would raise the question, who of you is using regular expressions? All right, that's good. So let's take a look at the first demo, and this is also a demo at the same time, I hope, for the version 2 of my ISE steroids. This is the first public meeting where they can show off, and let's see if that works. Okay, now what I want to parse is this. I want to take the Windows Update log file, and as you can see, as a human being, there is a structure. There's information that has a delimiter, and that's very typical for tabular-oriented data. In this case, it's a tab. So how can we write a parser for that? Here's a script. First of all, I am reading in that information. That's very easy. I have get content. But yes, of course. But then I want to do something with it. In this case, I am processing each line, and this is a habit of mine. It's optional. I always store $_ in a meaningful variable, so next week I know what it is. And this is basically the heart of this parser. It's simply split. I don't use any regular expression at that point. I'm simply saying, hey, I split that stuff at the tabular delimiter that I identified. Then the last part was that the parser was supposed to return rich objects. And that's the best way, in my opinion, to do that. I'm creating an ordered hash table, which is new, I think, in PowerShell 3. You can use a normal hash table if you want to, but the ordered hash table guarantees that the order of your properties will remain in this order here. And then once you have a hash table, you can simply turn it into an object. So I'm splitting that stuff, putting the information into my hash table, and as you can see, I'm not putting all of the information into my hash table. I'm simply, from the chunks that I get from each line, I take the first element, the second element, and the last element. Because I found that in my log file, in this example, the first was the date, the second was the time, and the last was the product. So when I run this, it takes a couple of seconds, and then I end up with some information. That is my log file, my raw log file, now parsed and put into real PowerShell objects. Each line is an object, and each object has 3 properties. That's a basic principle that you can apply to many, many different log file types, because the only things you need to adjust are the delimiter. If you have a comma separated log file, you simply replace that with a comma. And of course, you need to pick the pieces, the chunks of information that are useful to you. Here's a slight variation of the same thing. What you can see here is I get the same content, but I do pre-filtering. That is obviously very useful. Since this whole thing is text-based, before you let the parser turn it into objects, it'll speed up things considerably if you sort out any lines that don't contain the information you're after. If I wanted to see only the updates that were lately installed on my machine, I would obviously only look for lines that are successfully installed in them. And this time, this thing is a lot faster. As you can see, here I have my updates picked out of my log file. Still, this whole thing took, you can see it down here, 1.69 seconds. And we were talking about performance this morning already. Here you see again a slight variation, but this time I am investing memory in turn, and in turn I get speed. This time I'm avoiding the pipeline, which is a very great construct. It's very stable, and it's saving memory, but if I need things to happen fast, in this time I'm reading in the whole file in one step here, and then I can sort of process the whole thing in memory. And when I do this, it's much faster. It's 0.3 seconds rather than 1.7 or something. And if it's a large file, you can imagine the speed difference. So that's in general a very interesting decision that you can make whether you want to invest memory or not. Oh, that's one step further. Now that was parsing of a plain text file simply by using split. That's all you needed. But you all raised your hands when I asked who of you has done things with regular expressions. So maybe you're sorry you raised your hand, so we have to look at regular expressions as well. Regular expressions give you a lot more freedom. I'm not going to dive into regular expressions, but they are sort of like a search warrant. You can create a pattern and then find that pattern wherever you want in your text. And so here is a slight variation that shows how that would work. It is basically the same thing. I'm having that file here, and this is the pattern that I'm using, but I want to show you how you can derive from a regular expression pattern objects in almost one step. Most of you will recognize this a digit, and there's a quantifier, so 4 digits, then /2 digits, /2 digits, and so on. But if you add a label to it, so if you put parents into your pattern and label the pieces that you're after, you have a date, I have a time, and when I go on a little bit further, I have my message, which is right here. Then the match operator will tell you true or false, whether it matches or not. And if it does match, what you get back is a hash table with the matches. And the hash table uses exactly those keys that you decide that you did. Oh, it did something.
Very good.
Magic. All right. Thank you, Richard. Can you stay here, please? So basically, you can take matches from match and turn it right into an object. However, matches is a regular hash table, so it's not an ordered hash table, which requires you to use select object to sort out the expressions you want and the order in which you want them. But other than that, it works fine. If I run this, it'll again parse my file, and you can see date, time, message. That's exactly what I used up here, date, time, message. If I renamed it here, obviously here too, then everything would turn in, the name would turn in all my objects. You can do this very same thing with an ordered hash table as well. So I take an empty ordered hash table, take my regular expression matches, and simply take out the information and feed it into my ordered hash table, and then create my object from that ordered hash table. This would give me a couple milliseconds benefit because I don't need the select object anymore. But other than that, it's basically the same thing. All right. So that was the hard part, really. I had to create the parser myself, either choosing the split operator or come up with some kind of magic regular expression thing. But you can also use existing parsers if you are thinking about it. The most generic existing parser that you have is the one for CSV. And when you think about the essence of CSV, then the essence of CSV is simply it's a tabular data format, so it's one data set per line. It has a unique delimiter, and it has headers. Once your data meets these requirements, and many log files do, you are in the game. So simply turn your raw data into sort of this format, and thanks to the PowerShell team, the commandlets that usually process CSV are versatile enough to support slight variations. Take a look at how much easier it is to use those existing parsers. So I'm switching now to the other solution, and that's it. That is basically doing the same thing. I again have my file here. Now my log file did not have headers, but I can supply headers. And the easiest thing for me to supply headers is simply to provide a list of numbers, because I don't know what those columns mean, so I just take 31 numbers, so I have 31 column headers, and that's all I need. I tell import CSV, hey, I don't have a CSV, I have a tab SV, so I take a tab, and that's it. When I run this, I get the very same result. I get rich objects. I don't have to do very much. You can see the columns are my numbers. So that's really, yeah, well, that's cool, isn't it? And we should clap for the PowerShell team because they made it so versatile to use. I really like that. And then once you identified what the columns mean, like I do it again, I can easily see column 0 is the date, column 1 is the time, and so on. Then it's just a piece of cake to move on and simply replace those numbers with a meaningful text. I just replace the ones that I identified, the rest I keep numbers. So this time I get back something like that. It's parsed. So it's only mimicking CSV, but then it can use. And then also do this, and also do high performance. Oh, I'm already in the game. Great. All right. So that is really a very interesting technique that you can use. And you can use it multiple ways. For example, in the previous example, I used import CSV. Import CSV was taking care of everything. It was reading the file and then turning it into CSV. Here's an alternative, using get content and then convert from CSV, which when you do it like that is a little bit slower because it is reading line by line by line, but it gives you the benefit of pre-processing the data. So you can basically read in the log file and then sort out all the lines that you don't need, that don't contain the keywords you're after, and only convert those that you are interested in. So this one would be, in essence, a little bit faster. It still takes about 3 seconds. I think, yeah, here I didn't output it to grid view anymore. You've seen that the data is there. I wanted to focus on the number of results that I get. So 54 results, 54 updates were installed. And here is a variation that I would like to show you. You have to focus on the status bar. I'm going back to the previous example. This one takes 3.63 seconds. It's not outputting anything, but it's just retrieving the data. Now I'm doing the same thing with this script, and it takes 2.3 seconds. Well, at least 30% faster, only by adding this. This time I was telling getContent to read in the string array in one chunk rather than line by line by line. So my pipeline only handed over one object, which was the string array, rather than 13,000 lines of string objects. Provided that your commandlet can accept string arrays, that is a good optimization strategy.
Just as an aside to that, so we ended up having to switch over to using the stream reader for performance reasons. If we'd done that, would that have done the same thing in effect?
Yeah, it depends a little bit on who's receiving it. If convert from CSV can deal with a string array, then everything is fine. If it needs to get in strings, then you would probably have to not use read count 0.
Also in PowerShell version 3, we added -raw.
Yeah, that's. Wait a minute. I'll be right with you. It's right here, raw. So that is basically also possible. Raw will read the whole text in one step and then feed it into convert from CSV, which of course requires that commandlet to accept raw text.
I tried that when I was parsing text logs. In the end, I went back to reading line by line because I like the ability to find the line in the log after I'd found the issue.
Exactly. It depends on how you implement it. If you want to go line by line, then of course you need getContent to provide you line by line, which you can do in both ways. Both the plain commandlet and read count 0 will give you all individual lines in a different way.
So what I ended up doing was I was trying to find there are random events with the software that had issue, and if there were 5 of them in 20 lines, it was a real issue, and if there was 1 in 20, it wasn't. So it was using the line count to give me a crude timeline of what was going on, basically.
Right. Yeah, if there's nothing wrong in using getContent without these optimization strategies. You just have to think about, do I need it? Do I want lines, or can I process the whole text? And basically, here's again a strategy that you've seen previously. This would be the in-memory approach. Even if I use raw, it still takes about 2 seconds. If I use the in-memory approach, so I'm reading the whole text first and then processing it with the classic for each, then the whole thing only takes 0.3 seconds. So again, this can make a real-world difference. This is not a very large file, but you have to be aware of that you're burning lots of memory. That's the downside of it. So we have seen 2 ways of parsing text files so far. One was using simple text splitting operators or advanced regular expressions. That's your own parser. Or you are kidnapping one of the parsers that are built into PowerShell. That makes life much easier. And now let's go one step further. Oops, sorry. The same principle that you've seen here for log files applies to any kind of raw text data. And there's a lot of interesting and useful legacy commands that by nature return text as well. And since PowerShell allows redirection of console-based commands, it's very easy for you to get to that text. It's just a matter of parsing it. So the even better part is that lots of those commands have a magic option, FO, format output, so they can already provide you with CSV data. You don't even need to parse. You simply need to remember that CSV, or that PowerShell, has diplomatic relationships to CSV. Once you have CSV, PowerShell can read it. So all of these commands, and these are not the only ones, have this FO CSV. And that can give you a lot of interesting information, and you can then, once you have it, optionally also post-process your information. What I mean by that, you'll see in a second, because you will eventually run into localization issues when you process raw text data, and that's not good. We want to fight that. And then, of course, there's a special challenge. When you remember, the tabular format of data always requires a delimiter. So you can already process comma-separated, tab-separated, and stuff like that. But what about fixed width columns? There is not one separator. It's filled with spaces so that all the lines, all the columns align pretty. We have to find a way to get these into the same scheme. Now, first of all, here's an example using system info. System info, who knows system info? you will see in a second, you'll witness in a second how PowerShell can turn this into a unique system information tool, because when I run it like that, what I get back is the information, okay, but it's well, not really easy to use. It's simple text. I can't do much with it. However, if I add this magic FO CSV, then the whole thing will be CSV. And then PowerShell can read it. So basically, when I do this here, let's do it a little bit different. Oh, see? Hello. I want to add something. I can't. I'm in presentation mode, sorry. So I'll do it like that. I'm simply running it through convert from CSV, and you'll see that you get back an object with object properties that you can ask. So if I store this information after I have converted it into a variable, then I'm in the game. That's all I need. So now, once I have this, see what I can do. I can say info dot, and here's my information. That's all I need. It's right there. Domain is this, okay? Pick something else, and you see there's one challenge though. It took the headers from the original CSV, and they may be either localized or they can even contain special characters like spaces and parents, like this one. PowerShell can deal with it. It'll just quote it, and it'll work, but it's not nice. So the first step would be really to convert it from CSV data to rich objects, but then you need to take one more step. Let's see if you can see what this line will do. Anyone has a suggestion what this line would do? But there's a comment over it. It is basically CSV data, so it is line-oriented data. So if this is CSV, and I take only the first line, then that's the line with my headers. So that's a CSV header line. And clip.exe is a convenient tool that simply pastes the stuff to the clipboard. So I run this. I get my first line. And now, let's go here. If I, for example, define the variable header equal, oh, English, that's why. Header equals, and then paste that in. Here are my headers. As you see, isosteroids is underlying in blue because it's supposed to be all single quoted, so change it. And also do it like one array per line. And then here you have all the different headers, and now you can change them. You can make them cultural neutral. You can call them as you like, which is what I prepared here. Like a good TV cook would say, yeah, I prepared something for you, and it's right here. I just went through the original headers and renamed them, and then it's simply a question of skipping the first line, so the original headers are not used anymore, and then adding your own headers. So you're cutting off the original headers, replacing them with your headers, and the result is now it's a cultural neutral approach, no matter where the data comes from, French, German, Italian systems, and you can decide whether you want to have special characters in them or not. And this thing, system info, actually has a switch called S.
Oh, wait.
There we go.
Hey, all right. Thank you. All right. Now, this was parsing where you provided the parser or you provided data to an existing parser. In PowerShell 5, there's a new feature which is called example-driven or example-based parsing. And it can deal with any kind of data. It's obviously a very nice thing to be applied to complex data where it's not the typical tabular design that can be easily parsed the way I showed it to you. And it works like this. You train a commandlet. There's a commandlet called convert from string. And you simply train it. If you know speech recognition, you also know it takes some time till that thing understands you. You have to talk to it so it can learn your language. And the same is true for this commandlet too. So you train it with a couple of data sets showing where the interesting data is, and then leave the entire parsing to that commandlet. It is using something called Flash Extract from Microsoft Research, and I think Lee can tell us later on much more about it. I just want to show you the idea behind it. I really sincerely hope it works now. Okay. So this is what I want to parse. This is a vendor list with MAC IDs or vendor MAC IDs. So the first 3 digits are the vendor IDs of a MAC address, and then there is the vendor who is producing that network adapter. It's a long file. You can see it, very long file. And if I wanted to apply my strategies to it, it wouldn't be that easy, because there is no one delimiter that I could use. So before I show you the actual code, I created a little wizard that helps me illustrate what it does. So I'm loading basically my list. It looks like this. And now I'm providing examples. So I'm saying, hey, I know this thing here, that is going to be a MAC address. So MAC. And this one is going to be the company. Company. And you can see in this, let's take one more thing. This is the country. Huh? Country.
This is an ISC steroids?
Yes. And you can see what it did. It put a label around these instances, and I'll provide one more, just so that it knows I mean it this way. So Mac, company, and United States. And now, since this is a very large file, the best thing to not get frustrated is to not scan it entirely from the very beginning. So I'm simply putting a breakpoint in here. I'm saying, I want to parse till here, limit data. So now it's limited to that amount of data, and now I'm test driving it. And as you can see, that's what's the result. It found all the data sets, although I only sampled the first two. Although when you look at the data, it was easy, right? Because there's always the same company at the beginning. So let's see what's happening when I extend that reach. So I close this, and I'm extending it. Let's say one more data set, or two. And try it again. It failed. And now the question is why? Since, well, I can either think or I can invest time. If I don't want to think, I invest time. So I invest time now. I'm simply, until here I could parse it. So here was the problem. Let's simply label it so it can learn more. Company and country. And let's try that. Works. So you can always go to the spot where it didn't work anymore and provide another sample. But you could also think about it, why it broke exactly at that position. And if you look at it, you'll see that the problem was until here it thought it was numbers. Then I had a 0A. 0A was a letter. So since my sample data only contained numbers, the automatic parser generator thought, well, this doesn't fit in. Once I added that example too, so it could learn that there is also letters in it, I was in the game. And I could go on like that, for example, by just going one, let's go to Cisco here, limit it to Cisco, test drive it. And as you can see, Cisco is recognized, but the country isn't recognized anymore. So now I would again add one more sample so that it could learn that there can also be commas and dots in the company name. Let's do that as a last thing here. Mac, company, and country, and get more data. Let's go till here. Okay, and it works. And so you could go on step by step, or now we can generate the code. The code behind this would look like this. This is my code that I just created. There is the sample section. That's the samples that I labeled. And then that's the code that I need. And basically, when you play with it, what I would recommend is really to look at this line here. I'm reading in the raw data, which can be very large, but so that you can do it chunk by chunk and in smaller steps first to understand what it's doing, simply add a select object first x, and then only process the first x elements of that file. This is the magic. Convert from string. It takes your template, the template up there, and well, you don't have to put that in there. And then that's it. It either works or you have to provide more samples. The samples themselves, they, as you can see, use these braces. And it's a very simple thing. You have braces around the areas that you find interesting, and you have a label that labels them. So the MAC address is always the MAC. And then you have to also put in a star for the first field of a data set so that it knows where the data set starts. So the MAC has the star, and all the others don't have a star anymore. And another thing to note is if your original data happens to contain either braces or backslashes, then you need to process your template a little bit. Because as you can see, the brace has a special meaning. So if there is a brace in the raw data itself, you need to escape it with a backslash, which is done by this wizard automatically. And then the other thing you have to be careful with is the backslash. It's an escape character. So if you have an escape, or if you have a backslash in there, you of course need to escape that too. But again, there are tools out there, and there are going to be more tools out there, I guess, that will help you play with that. This is not to replace the other strategies. It's simply another option that you have if you have complex data and you have no idea about regular expressions or not the time to dive into it. You can go this route. Okay?
How much can you modify the template? I mean, you have these different tags there, but and how intelligent is it? Or can you put in regular expressions there as well? Or?
You have the option to also use regular expressions in there. For example, if you have empty fields, you can say \s, which would then be just a white space. But to be quite honest, like Jeffrey said, or I don't know who said it, if it's not the final product, you don't have documentation that much. So there's not that much documentation. We should talk to Lee what kind of...
Try to slash W instead of United States?
I think that should work. I just tried it with /s, and that worked well. But you're right. This is the example that I took directly from the data because I didn't want to think. I simply labeled. Of course, you can think too, and you don't need to take actual data. It is sufficient to have sampling data. So if I know that, for example, my MAC address can also have here a letter, then there's no one keeping me from putting a letter in here and teaching the system this way. So it can be sort of, these data sets don't have to be real data.
Is it based on regular expressions in the back?
There is something like it.
That's Lee.
Yeah, Lee, you should. It's not exactly regex, right?
So the idea is that the research project behind this is based on a technique like regular expressions. It learns programs based on your data. So in regex, you have like words and spaces and numbers. The underlying language has been extended to talk about text manipulation commands. So like moving down a line, moving right a line, and just other things that you would do when you're extracting data aside from just regular expressions. So then based on the training data, it automatically learns the most general program, or the most specific program that can hit all your examples, and then it uses that.
Is this shared with the Excel flash fill feature?
It's not shared, it's the same team, and so we've been working with them.
Okay, thank you. I think this is going to be a very hot topic, and I'm sure we'll all be talking about this tonight, maybe with Lee. Lee. Well, this is another approach. It depends always what you wanted to do. And I want to talk about talking to Neanderthals. So to plain text, unstructured data, if you use the experience-based learning that you've just seen, you can parse really complex data. But even if it is complex data, if what you want is very simple, then you can also come up with your own parser. This, for example, would simply read in the MAC vendor list and then use the in-memory approach to simply look for something that matches my regular expression out there. And the regular expression, of course, I would never come up with a regular expression that picks MAC, company, street, and country, because that's spanning multiple lines. But if all I want is a mapping between the MAC and the company name that's all in one line, then that's a fairly simple regular expression. It's well, the bad part about regular expressions is it's harder to read than to write. So it's really hard to read, but to write it's very easy. It's simply a hexadecimal, 2, then a dash, and so on. That's the 3 hexadecimals. Then it is basically this fixed anchor hex that is in each line. And then this one is just one or more white spaces, and then the vendor with anything that follows. So this would parse the entire line. But it is doing something when I am. Okay, maybe it's. Okay. So when I run this, really carefully, let's do it this way. Okay, I can see that Well, that's obviously not true. It's a lot more than 54 in there. Let's just move on. Because the thing that I really wanted to show you is, if you parse a file like that, you can, of course, create a lookup table. I don't know if any one of you have done that before. When you take group object with these two parameters, then you get back a hash table where you can ask the property that you mentioned here for the value. So this would basically give me a lookup table where I can say lookup table dot and then the vendor ID and get back the vendor. But for large data sets, this takes quite some time. So the last puzzle piece that I wanted to give you is a commandlet that's been in PowerShell, I think since version 1, that many people don't have on their radar, but is very, very useful, and that's this one, select string. Select string is extremely fast and can be a great solution for...
You can't see it in the back?
Okay, I'll do it. I'll scale it. I hope that the display sticks with me. Let me just do it like this. Do it like this. So basically what I have here is I have a vendor ID. I have my vendor list, which is quite large. I use select string, and as a pattern, I'm simply using that. It's a simple pattern. It's not a regular expression in this case. I'm not using it as a regular expression. And then the fun thing about it is this does not only give me the line that has the pattern, but it also has a context. And I'm using context 0, 5, which means I want 0 lines above the matching line, but 5 lines after the matching line, which happens to be the address of my vendor. So that is a great way, a very simple way, to get a specific vendor out of it. Because what I now do is create my hash table, add the vendor information. This is, again, a little bit text splitting, where I say the vendor is the last word after the last space. And the information that I got from the context. Here's the context. The context is the post context, the 5 lines after the line that I wanted. So if I run this with my fantasy MAC address ID thing, what I get back is this. This was made by Intel, and that's where they live. Or where the card lives, I don't know. It's the information that was associated with that vendor. So again, this is lots of little scripts that, of course, serve as inspiration. You'll get them all, so you can take them and play with them. It's not, I don't expect anyone to really digest any of these samples in a minute, but I just wanted to give you a broad overview from the practical approach, what you can do. And I see this turns red, so I have to come to an end. And I am at an end, I think. See. Okay, I think that I can skip the rest. So we have done a little journey. We started with parsers that you created from scratch using split and regex, then use the existing PowerShell parsers, especially import CSV and convert to from CSV, and finally took a look at the new experience-based parsing in PowerShell 5. So that's it. Thanks for your time.
Press the button. It's the button.
Oh.
Red button.
Okay. By the way,